Okay, hello again. We're still concentrating on physics paper 2. And we're going to be talking now about resultant forces and work done. Okay, resultant forces and work done. So let's see if we imagine for a moment a car. I can't draw a car, so we'll just draw a box. And the car is moving. How can I show that? So the car is moving that way. Car moving that way. Now, there's the road. So I can probably do wheels. So there's the road on the car. And it's quite good to be able to do force arrows. So this force arrow going in the opposite direction to the direction the car's moving could be called friction. Could be called air resistance. And let's say that has a force of 1,000 newtons. The force acting down on the car, because as you can see the car's not floating in the air, it's actually pushing down on the road, and the force due to gravity is called the weight. So let's pretend for a second that the weight of that car is 1,500 newtons, because these are forces and they have to be measured in newtons. The car is obviously not going into the ground, it's obviously staying on the road, so there must be an upward force of the road acting on the car. So there's another force there, and let's pretend that's 1,500 newtons. And then we know that the car's going in this direction, and we're going to call this the driving force. And let's say that the driving force of this car is 1,200 newtons. Okay, so you might be asked, what is the resultant force? And this is something that everybody can do. Okay, it's quite straightforward. So the force acting upwards is 1,500 newtons, and the force pulling down is 1,500 newtons. If there was no force pulling it down, then the car would start going into the air. If there was only a force pulling the car down, the car would go into the ground. So because it's exactly the same, the car doesn't go up and it doesn't go down. Now if we look at whether the car's going that way or that way, the force making the car go that way is 1,000 newtons, but the force making the car go that way is 1,200 newtons, so it's 200 bigger. So the resultant force is 200 newtons in that direction. Okay, so the car would go forward. Now, the title for this bit was Resultant Forces and Work Done. So that's the resultant forces. Let's do the work done bit. So, equation that you should learn is work done, which is measured in joules. And that always sounds a bit tricky to understand, isn't it? Work done in joules. But it really helps if you just remember that that is equal to force, and we know that that is measured in newtons. So we don't really write joules like that, we just write a J for joules, is newtons times the distance, and the distance is measured in m for meters. Now it's really important that you get these units exactly like they are. If they gave you kilojoules, you'd have to times it by 1,000 to get joules, because this equation only works if the units are exactly like it is there. If they gave you a question and it was in kilometers, you'd have to times that number by 1,000 to get meters. Okay, so try to remember the units as well as the equation. So if you've got the car, so the car travels at 10 meters. It's got a force of 10 newtons. Then you simply do distance, which is 10, the force, which is 10, you multiply them together, so the work done, 10 times 10 is 100, but you get a mark if you say the J as well. Okay, really important. Okay, that's the end of part 2. Thank you.